Equilibrium concentrations, part 2. I'm Mr. B. Given this equation, H2 plus Br2 is in equilibrium with 2HBr. Calculate all three equilibrium concentrations when 0.500 mole of each of H2 and Br2 are mixed in a 2.00 liter container and a Kc value of 36.0. Notice that moles are given and volume of the container is given. However, the calculations must be done in molarity. So we must divide 0.500 by 2.0 to get 0.250 mole per liter, or simply 0.250 molar. We will use an icebox. Here the initial row has been filled in already, where the concentration of H2 is equal to 0.250 and the concentration of Br2 is also 0.250. The concentration of HBr initially is 0. Remember, the last value of 0 comes from the fact that the reaction has not yet started, so no HBr could have been produced yet. Now for the change row. Both of the reactants are being used up, so we must use minus X for the reactants. Since the product is being formed, we must use a plus sign in front of 2X. The 2 is important. The 2 means that HI is being made twice as fast as either H2 or I2 are being used up. To determine the equilibrium concentrations based on this data, simply combine the initial concentrations and the change in concentration. We may now write the equilibrium expression, where Kc is equal to the concentration of HBr squared divided by the concentration of H2 times the concentration of Br2. Plugging the values into the expression gives the following, where the value of Kc is 36.0. So 36.0 is equal to 2x squared divided by 0.250 minus x times 0.250 minus x, which simplifies to the following. 36.0 is equal to 2x squared divided by 0.250 minus x squared. This represents a perfect square, so we may now take the square root of both sides of the formula. Taking the square root of both sides of the equation yields the following. 6.00 is equal to 2x divided by 0.250 minus x. Now for a step-by-step method to solve for x. 6.00 times 0.250 minus x is equal to 2x. 1.5 minus 6x is equal to 2x. We must now add 6x to both sides of the equation. This yields 1.5 is equal to 8x. And after dividing through by 8, we get x is equal to 0.1875 molar. We may now find the true equilibrium concentrations. The concentration of H2 is equal to 0.25 minus 0.1875, which is equal to 0.0625 molar. The concentration of Br2, likewise, is equal to 0.25 minus 0.1875. This is equal to 0.0625 molar. And the concentration of HBr, which is equal to 2x, is calculated as follows. 2 times 0.1875 is equal to 0.375 molar. So the equilibrium concentration of H2 and Br2 are both 0.0625, and the concentration of HBr at equilibrium is 0.375 molar. This completes my lesson on equilibrium concentrations, Part 2. I'm Mr. B.